Hello students, in this video we are going to discuss parallel in, parallel out shift registers and also parallel in and serial out shift registers. First we are going to discuss parallel in, parallel out shift registers. The speed of operation is very fast, that is transmitting data and receiving data is very fast when compared to the serial input and serial output, but the number of wires requirement to transfer the data and receive data, we need more number of wires. So when compared to the serial input, serial output, in serial input, serial output requires only one wire to transfer the data, right? And receive data we need one more wires, but here we need more number of wires to transmit the data. For the 4-bit flip-flop or 4-bit parallel input parallel out register, we need 4 wires to transmit the data and 4 wires to receive the data. So the number of wires are more, so when compared to the serial input serial output, but the speed of operation is very fast when compared to the CISO, right? Serial input serial output. Here, so we will take this one as a positive edge of the clock. All the flip-flops are triggered at a time. So we are transmitting the data for the each clock pulse. We are transmitting all the 4 inputs data at a time for the each clock pulse and receiving the data at a time. Okay, so we are transmitting D0 data, D1 data, D2 and D3 data for the clock pulse 1, right? For the clock pulse 1. So all the 4 flip-flops receive the data and it gives the result at a time at the Q0, Q1, Q2, Q3. Once it receives the data, so it at the receiver side we will get the result. So we are get the result parallelly. So we are feeding the data parallelly, right? We are feeding the data parallelly for the at a clock pulse and we are receiving the data parallelly at a time. Okay, so we call this one as a parallel input parallel out shift register. So parallel in and serial out register. This is a parallel in and serial out register. For the 2 marks they will ask this question. So that time you need to draw this block diagram along with the truth table. You have to write the truth table, right? Here we are using the 2 parameters, shift and load. Shift is a active high, shift load is an active low. So if you are giving shift as a 1 means, so it performs the shift operation. If you are giving 0 means it performs the load operation. So before shifting we have to load the data into the flip-flops. Here we are using the 4 flip-flops because it is a 4-bit parallel in and serial out shift registers. Okay, first we need to load the data. So whenever the input is 0, load is 0, so we are getting at the output of the inverter as a 1. So that 1 is transmitted to the AND gate of G1, G2, G3, G4. We are enabling the AND gate G1, G2, G3, G4, right? So we are disabling G5, G6, G7, right? So now we are feeding the data to the each flip-flop through the gate of G1, G2, G3, G4, right? So at the input of data we have one OR gate, right? So through the OR gate we are we are feeding the input for the second flip-flop, third flip-flop and the fourth flip-flop, except the flip-flop 1. In the flip-flop 1 we are giving directly the AND gate of the output of AND gate of G1, right? So once if we are storing the data parallelly for the each flip-flop, now I need to perform the shift operation because it is a serial out register. So I need to perform shift operation. So now if the input is 1 means it performs the shift operation. For this one, um, G1, G2, G3, G4 are disabled, and G5, G6, G7 are enabled when shift operation is 1. Okay, so once the shift operation is 1, so it is ready to shift the data from first flip-flop to last flip-flop. So now here if you are storing 1 means this 1 is enter into the G5 and shift is also 1. So your here G2 is disabled. So your G5 output is 1, your R output is also 1, right? Now the D1 stores 1. So Q1 output is 1, right? Again here is also 1, here is also 1. Your D2 output is 1. The Q2 output is 0. So 0, 1, 0 is 0. Again here your R is 0. The last flip-flop stores the 0. Whatever the data stored in the D3, so we are receiving that one as a 0. This happens for the clock pulse 1. For the clock pulse 2, again it performs the shifting operation, right? So now here we are storing 1, 1, 0, 0, right? So now it performs the shifting operation. So 1, 1 means it stores the 1. Here now the Q2 is 1, right? So the Q2 output is 0. It enters to the D3. So your Q3 output is 0, right? For the C3, Q2 output is 1. For the C4, Q2, Q3 output is 1. So your final output is 0, 0, 1, 1, right? Double 1, double 0. So like that we are transmitting the data parallelly and we are shifting the data in order to receive the data serially. This is a right shift. Okay. So in the next class we are going to discuss counters. We have two types of counter: synchronous, asynchronous counter. In your exam they will ask either synchronous or asynchronous counter. So again in the synchronous and asynchronous counter we are discussing up and down counters. Thank you.